can see it.
All right. Well, thank you, first of all, Brent, for doing this very first web presentation series thing. But definitely still just trying everything out, seeing how we can best do this. Had a couple of glitches so far, but yeah, thank you. So I just wanted to say that the web presentation series is hopefully something we're going to continue to do, and it's a way for the lonely and semi-lonely coders to share cool things that they've been working on. You know, these aren't like this is the only way to do this one thing. This is just, you know, people figuring things out, being presented with problems, and presenting the rest of us with some solutions. So thanks to Brent for being the first one, the guinea pig here. I think we're all just kind of like here to learn from each other. So any questions that you have, you know, feel free to post in the Slack if you're watching this live. Yeah, Brent, I'll let you take that away.
Cool. Okay. So yeah, thanks for everybody who could come, and I wanted to talk a little bit about a thing that I built that lets us save some data that's posted to a website and save it up to Amazon and do it all automatically without anybody needing to be involved with that process every day. So you should be aware that I'm not an expert at this, at Python or at Amazon Web Services or anything like that. I learn by looking at examples and trying stuff until it works and breaking it and trying it again. It's hard to figure out sort of what everybody's base level of knowledge is. So if I gloss over some things that you don't know, please feel free to ask. Or if you know stuff that I don't and can figure out ways to make this better or solve some of the problems I'm going to talk about, I would love to hear that too. So here we go. Let's talk about a little bit about what we're going to talk about. First, I'm going to show you the site that I want to scrape. Then we'll go through some of its red flags, and then I'm going to show you the code that scrapes the site, and we'll talk about how that works. Third, we'll talk about how I got it working on Amazon and why I chose to get it working on Amazon. And then finally, I'll talk about some of the concerns that I have about this and about the script and Amazon and how they work together, and also some of the features that I'd like to eventually get around to adding to this. So here's the situation. St. Louis puts up a ton of data that we might want to use. So most of it gets updated every day, but there's no way of accessing any archives or anything with it. So you get the current day's data, but if we wanted to make comparisons to the past, there's no way of doing that, no way of looking at changes over time. Also, I wanted to be able to do this automatically without having to remember to do it every day, because I initially wrote a script that I triggered every day and it downloaded the data to my hard drive, which worked except when I wasn't here, or you know, when I was sick, or on the weekends, or if I just forgot to do it, we would be missing some data there, and I wanted to try to solve that problem. So like I said, I wrote a script that I triggered manually and downloaded some data, but then to automate it, I decided to pair that with Amazon Web Services. So using the EC2 service, you get a script, or you get a server that you can automate triggering the script with. And then using S3, you have relatively cheap storage space for all of the files that the script then downloads. So here's the site. A few red flags to note. We don't want to download all of the links for a couple of reasons, because some of the links point to things that are not data. They'll point to descriptions of things or whatever. So we don't want to just look for all the links and download them. That wouldn't be sufficient. Two, some of the data files don't get updated every day. Some of the stuff is old. They only need to update it once every year or a few years or month or whatever. So we don't want to just go through all the links every day and download everything because we'll duplicate a lot of files. And so finally, the file name doesn't change at all. So if we just downloaded the files as they existed, we'd overwrite the files every day, which is probably how they update this website. But we would get, for example, this parcels file would just be named parcels.zip, and you wouldn't have any indication of when you downloaded that. So those are some of the red flags with the site and things I had to watch out for when I was writing the Python. So let's talk about the code. I'm using Python 2.7. And on the left, I will have some explanations. On the right, I'll have the actual code. I had to split it up, and hopefully it's large enough for you to see. So first, we have to import some packages. So these are the packages that this script is using. They handle some of the more complex functions. And you can read what each of them does over there. Some of these are extremely powerful things, like Beautiful Soup is very, very powerful in terms of parsing web pages, and the bottom one, Boto 3, lets you do all kinds of crazy stuff with Amazon's web services. And for these, I use a virtual environment and pip, which I've set up on my machine to manage these, and that way you can sort of create, it's almost like creating a little sandbox for each project that you're doing, so these things won't conflict with each other, and that's kind of nice. So now on to the actual script. After we imported those files, first, this is the function that uploads the files. So we give it two arguments, the file name and the content. What we want the file name to be, what we want the content to be, the script prints that it's uploading it, and then it uploads it. That's pretty much it. So the name of the bucket you can see is hard-coded in there. That's the STLPR-STL-city, all of that. That's the name of the bucket on Amazon that it's actually going to. So all this does is it takes the file name and content and uploads to S3, and that's pretty much it. So it's a pretty straightforward thing, and it's using one of those packages that we installed earlier. So now we'll move on to the main function, which I called archive. First, I have to set up some environment variables. They let the upload function sort of do its thing by proving to Amazon that I'm me, because you don't want to just load everything into, you don't want to let anybody upload stuff into the bucket. You want to make sure that you're the only one who can do that. So these are loading environment variables, which you set up outside of the script. So that way I can show you the code, but you don't get to see the actual keys that I'm using. If you knew that this code wasn't going to go anywhere else, you could hard code those in, I guess. But this way it's a little more secure. We are also at the bottom of this setting up a global variable, the S3, that points to the S3 resource. So next, we want to do a little bit of background work that lets us avoid downloading things more than once, just to save space, to save time, to save the load on the city server. We want to make sure we're not downloading things more than we need to. So we want to access that bucket where we're saving everything on Amazon. We want to look at everything that's inside there, and then iterate through those file names and add them to a list. So at the end of this, the list called downloaded is going to just have a list of file names that are in that bucket. So next, we need to open the web page. That's what this code's doing. That URL lib2 is a library that's opening the web page, and it passes the result to the Beautiful Soup module, which I talked about earlier. So it is parsing that web page, and then finally the the last bit of code here, we trim out all of the navigation stuff because we don't need any of that. We just want the content. So we're looking for the element with the ID of content and saving that to a variable, and that's what we're going to work with next. So this is the rest of the code. I hope it's big enough for you to see. If not, we can take a look at it in more detail at the end here. But I'm going to just kind of skim through the part that analyzes the actual web page, because every web page is different. So you know, the likelihood that you're going to need to scrape a page that looks exactly like this one is not very high. So the details of this aren't going to be that important. But I will let you know a couple things that I ran into that are interesting. First, I know that because of the way the page is set up, I'm not interested at all in the first list item, and so we can just skip it. So in that line 43, under where it says content.findAll, LI, that means that, you know, find all of the list items. Give me all of those list items. But then right after that, in brackets, the 1: is Python slicing notation, which means take the second item. Python is 0 index, so 1 stands for the second item. So take that second item and give me that item plus everything all the way to the end. So it's basically just saying, throw out the first item, I don't need that, then go through the rest of those. So for each of those list items, I find a link inside of them. But I'm only interested in zip files. So like I said, there are links all over this page that aren't zip files, and I don't really care about those. So if you're looking for a specific type of file, what you can do, as I did in line 45, I got the hypertext reference element. So it would have, say, the file name .zip. And then I'm going to split it on the period. So you take everything before the period, that's the first list item. Everything after the period, that's the second list item. And again, I'm only interested in the second part of that, just the file type. So I put in a 1 there to get that second element, which should be the type of file that I'm looking at there. And in this case, I'm only interested in zip files, so that's what I'm comparing it to. So it's saying, take a look at the file name, get everything after the period. If that's zip, then keep on going. If not, go back to the beginning and try the next one. So that's what I'm doing there. And that is in line 45. So after that, we're going to, let's see. After that, we need the date that the file was updated, so that I can create that better file name that I'm looking for. Like I said, the file names as they exist on the page are just the name of the data, so parks or streets or whatever, and you don't have any information about what date that was. So I would just keep overwriting the file if I kept downloading it. So we need to create a nicer looking file name. So to get that, we're going to grab all of the text from the description and get the last line, and then count backwards to get the date. Since the date's in a predictable format, I can just choose the last, say, you know, the year in line 55 is saying, you know, take that text and count back 4 characters and then give me whatever those 4 characters are, and that's going to be the year. Because they do the date in the same format every time, that's always going to be the year, so save it to the year variable. And then finally in line 58, we're creating the new file name using all those variables, which in this case is year-month-day- their original file name. So you wind up with something like, you know, 2015-10-16-parks or something like that, parks.zip. So that's what